So another example of factoring. So we have n squared minus 14n plus 40. So we're trying to figure out what to put in these spots so that we FOIL back to this expression. To get n squared, we first have to put n and n, because n times n for first will give me back that n squared. Then to find the numbers we put here, we have to multiply to positive 40, and those two numbers that we multiply also have to add to negative 14. So think about signs. If I'm multiplying to a positive number, the two numbers that multiply to 40 have to be either both negative or both positive. If they're both positive, then when we add them, we're not going to get a negative 14. So for example, 20 and 2 multiply to 40, but 20 plus 2 gives me 22. That's not what I want. So these two numbers have to both be negative in order to multiply to a positive and add to a negative. So they're both going to be negative. So we could put negatives there and negatives here. Then we just have to figure out what the actual numbers are. So let's try negative 8 and negative 5. So those multiply to 40, but when we add negative 8 plus negative 5, we get negative 13. That's not what we want. So what about negative 10 and negative 4? They multiply to positive 40, and if I add negative 10 plus negative 4, I do get negative 14. So that's what we want. If I were to FOIL this, I would get back the original, which is how we know we're doing this correctly. So I had a great question come up. This is no different than n minus 4 times n minus 10, right? It doesn't matter the order in which you place the factors. And this principle is because that you're multiplying this times this. So similar concept to the fact that 3 times 8 is the same as 8 times 3, right? They both give you 24 as an answer, right? Multiplication is commutative, so it doesn't matter the order in which you put the factors.